a short while ago I was asked if I'd be able to make some DIY cheap under kitchen cabinet strip lighting, and I thought to myself, well, yep, a while back I purchased a few reels of these 5 metre long 12 volt LED strip lights from eBay, and I thought, well, yep, okay. So I had to look around on the internet, and there wasn't really not really a how-to or a lot of information on it, so to speak. Not a lot that made sense anyway. So I thought, right, okay, it's what I'm going to be doing, so I might as well make a video. So originally I had got two different versions of white. The first one was cool white, which you may not be able to see that clearly with the exposure, and the other one is the warm white, which is the one that I was going to use for my still pending project. These strips, these eBay strips, I wouldn't say are the best quality. They're, as you can see, they kind of, I don't know if you can see there, but you get this little kind of loop here where the adhesive backing actually comes away from the PCB strip. Now with these, the manufacturer states, or say the manufacturer, the bag you get gives you general what you can do, what you can't do, but it does say must not exceed 5 meters when used in a DC series circuit. So I thought, okay, that's fine, I don't need 5 meters. There's going to be two separate lengths anyway. But I thought I'd test the voltage drop over the 5 meters, all the same. So 12 volts in, up to, let's see, up to this point here, which is one of the cut places. It gave a voltage of 11.79. So I thought, okay, fair enough, yep. Then you go down to the end of the first meter, which, funny enough, on these strips, they're not like any strips I've seen before. They are actually soldered together. Every meter they're soldered together. So I don't know whether these are these scraps from a company and they just come along and take them and do something with them. But anyway, at this point, it's 10.63 volts. Then right at the end of the 5 meter reel, it drops all the way down to 9.04 volts. So the opinion might be, okay, fair enough, so 12 volts will cover it, which is fine, and when plugged into a DC power supply, this does take 0.721 amps. So you can say, okay, then I could run this on a 1 amp, 1.5 amp DC adapter, that'd be fine. But what you'll notice is that maybe the first meter of this reel, the intensity may be quite bright. The further down the line it goes, and the more the voltage drops, there will be a decrease in intensity. So if you have from that first section 11.79 volts, to the end of the meter you're dropping down a volt, and then to the end of the reel you're dropping down another volt, it's going to be quite a difference. For example, if I was to plug this into here, you would see that as being the cool, yep, there we go, the cool white. Now if I was to drop that down by 1 volt, just that, this is the first section, drop that down by 1 volt, you can see it dim, 12 volts, 11 volts. If I was to take it down to 10 volts, that's 10 volts. If I take it down to 9 volts, there's 9 volts. So you can see what difference 12, 11, 10, 9 makes. in that respect, there's only, if you're going to use a whole 5 lengths, you would either have to use some sort of adapter. Disconnect that, throw that away. An adapter, which I also purchased from an amplifier, sorry, which I also purchased from the same people. Don't even see that. Yep, let's put it there. There we go. Just there. Which has got a peak output of 12 amps and a 5 to 24 volt input. Now this doesn't work. This doesn't work. I've tried it. It's dead. It's just, there's no point in even purchasing it really. So there's 2 options. There is the option of, because that will take a 1 amp to 1.5 amp supply. You can have your PSU. You can have your 5 meter. You can have your 5 meter LED strip, and you can power it from there 12 volts, say 1 amp. And that will gradually, it will start from here and that'll be nice and bright, and then it will start to deteriorate. Or you can buy some sort of splitter, or even make a splitter, and you can actually ring main it around, loop it, so as you've got 12 volts feeding in from one end and 12 volts feeding through the other end, and this would be a good solution to the intensity problem. In my case, I mean, the other option for this would be to actually do away with this wire and connect another power supply into there, but why would you want to? That just doesn't make sense. You may as well just run the wire around. In my case, because I have one strip light is going to be 180 centimeters and one is going to be 90, so I have my PSU there. That feeds into the 180 centimeter LED strip, and again here that feeds into my my 90 centimeter LED strip. Now if I was to join these 2 up via this 12 volt, say 1 amp power supply, and incidentally I have actually tested using the same test I did on there. I tested this, and with the same 12 volts, same DC power supply going into it, I did actually test it, and on the first section where are we? On the first section, which is just like the first cut off there, it came up as 11.92 volts. The end of the meter, it came down to 11 volts, and the end of the 180 centimeters was actually 10.79 volts, so there wasn't too much of a drop there, although it could be enough of a drop to notice. And that was drawing 0.48 amps, so you might as well say half an amp. The 90 on the same test, well, the first section, from 12 volts, testing at the first section, was 11.95. At the end of that strip, bearing in mind it's 10 centimeters away from a meter, was at 11.61, taking 0.29 of an amp. So yeah, it's not as much as that, but it's not to be expected. So if I was to connect these 2 together via a wire, that would actually be worse than that, because for every foot of wire you have, there is a voltage drop. So in this case, I would be better off either doing it like this, so as this would go round and connect to the end of that, so this is gone, that goes to the end of that, or I could have my 90cm there, my 180cm there, my PSU there, and then I can branch off. I can either have it the same arrangement as here, so I'd have that connecting to there, branch off, go down to there, nothing in the middle, or I can equally just feed it through the other side. That would be acceptable as well. I see no sense in doing the multiple power supply situation. That way this one is being fed the 12 volts, not tailing off to anything else. This one is being fed the 12 volts, not tailing off, and there's no wire in the middle here creating any more of a voltage drop than there should be. That would be an easier solution for that. And really there shouldn't be any kind of noticeable intensity problems. On the 90cm I don't think there's going to be any noticeable light problems there at all. Maybe, there shouldn't be here either, but maybe looping around like that and going into there as well as here may work. That could be an option, but for now I'll just be trying one to there, one to there. And the next thing with this is, because it's in a kitchen, I thought to myself, okay, fair enough, we're going to have kettles, we're going to have pots and pans, there's going to be moisture. This strip is not waterproof. This is IP20. So basically the rating for this is, it's not waterproof and it's kind of strong enough to it's got a protection rate of, I think it's 25mm, which means it can, you know, if somebody's fingers were to touch it, it's not going to break. There is an IP ingress protection, I think it is it ingress protection? Something like that, but it's, if you used to type in IP20 into Google, you'll actually get a chart up. But that's what this is supposed to be. This is supposed to be IP20, so I wouldn't chance this just, yeah, sitting under a cabinet with the kettle boarding. Second thing to notice is this backing looks like some, I don't know, I mean there could be an M there, I don't know. Could be M3, probably not. You can see, can actually see here, I've tried peeling some of this off before, and what it does is it leaves the actual, oh, the backing's coming off now, so there's the PCB, but it's not all that sticky. And when I tried to pull some off earlier on, the backing came off and the tape came off at the same time, so it wasn't kind of very good. So that is non-waterproof, whereas here is just a random strip I had lying about. This has got 3M tape. This has also got a, you can see it's got a dome, like a silicone dome over the top, which is waterproof. This can also be seen if you split here, you can kind of see that there's a, that was waterproof. That's an RGB cable, so that's not any good for what I want. So my next plan was to buy some silicone tubing. So I thought to myself, well, you know, silicone tubing sealed up should be absolutely fine. So what I did was I purchased some silicone tubing from a company on eBay. It was supposed to be transparent. As it turned out, it was milky, translucent, so it wasn't really what I was expecting, but I should still give it a go. And that is this stuff. Now this has a temperature rating of -60 to +200 degrees Celsius. The reason I chose this was because this is 5 meters. It cost £9.99 from eBay. If I was to buy the proper casing that's advertised with the metal back and the plastic front, for I think it was a meter, it was about £6.99, and considering DIY cheap job, this seemed a better option. And being heat resistant as well, the LED strips do get warm, but this should be able to contain it. Now with this, I intend to, well, I've actually got a piece of strip I've put into here. What I intend to do is use a silicone sealant around each end of the strip to try and seal it so there's no water ingress. I was thinking normal silicone sealant, but I know that some of them do have an acid cure and some do have a neutral cure. So anything with acid curing, or anything with acid in at all, cannot be used around any sort of electrical connection, because it will just eventually eat away and bad things will happen. The other option may be to glue gun the ends, because they're not going to be seen and it's not as though it's going to be put underwater. The glue gun option may work if it's packed in there. The tubing itself will be cut slightly longer on each end than is needed, purely because I want to pack in as much sealant, whether it's hot glue or sealant, as possible, just to make it secure. Now I've put this piece of strip in this tube, which may give us an idea of, bearing in mind this is the milk translucent, not the one that I actually thought it was, but it may give us an idea of exactly what it will look like. Maybe, possibly. Right, so here we have, now if I can hold that there, maybe turn these lights off, I may be able to get, oh here we go, so we can see the exposure, but we can see mildly that you can see the two exposed LEDs here and here, and then you've got the tubing, which almost gives the impression it's just one long light tube, quite similar to that, well not, yeah, the kind of the same idea as an outside rope light, I suppose. But yeah, that's I haven't seen any other videos that actually demonstrate that you can put the LED strip tape into tubing. Oh, incidentally, yes, the strip tape itself is 10mm wide. So if you are going to do this, the silicone tubing you need would have to be, and it's quite a standard size, there's only 3 sizes I think, but it would have to be 12mm outside diameter, and it has to be 10mm inside diameter in there. Don't get the 8mm because it won't fit. If you're going to run for this, it was quite hard to actually put in, because and it's only a short length, but you had to squeeze it. When I do the long lengths and put those through the tubing, what I intend on doing is, let's get my pointer, my intention will be to solder some thickish wire here, so not your thin stuff, but something that's going to be that you're going to be able to actually put through the tubing first. So in my case, I will cut 2 meters of wire, solder it to these tabs here, thread it through the tube, and then I shall pull the tape through the tube gently, and that's the way I'm going to do that. So that might be a handy hint for somebody. But apart from that, yeah, I think I've explained everything. You can also, if you don't want to use a DC adapter that you plug in the wall, and you want to plug it straight into the mains, you can get mains to AC, I think it's AC or DC, like mains to DC converters, LED drivers, and basically for these sorts of LED strips, because these are continuous voltage, continuous, yeah, CV, yeah, continuous voltage, you would need one of those sorts of drivers. You can tell that because if you've only got a resistor, like this one's got a resistor every 3 LEDs, then it's continuous voltage. If it is, I think it's continuous current, yeah, it is continuous current, then you would have, see that's starting to come off anyway, you would have a resistor and an IC somewhere on the PCB, and that could be a resistor here and an IC here, both on top, both on the bottom, wouldn't really matter, but that would be continuous current. So yeah, once I've completed it, I shall hopefully maybe post up a picture to see what it looks like. If not, then I will go for or try and find the completely translucent, not this, but I think this may give quite a nice ambient light spread. I don't know, we'll see.